if I said sine of 0 degrees, you fold in your thumb, so your 0 finger. How many fingers do I have above that? 0. So 0, square root of 0 over 2 is 0. Okay, what if I just went down? Cosine. So cosine is the square root of the bottom over 2. So radical 4 over 2 is, square root of 4 is 2, divided by 2 is 1. Tangent, you can get a couple ways. Tangent, we've said before, is sine divided by cosine. What's 0 divided by 1? 0. Or the hand trick, square root of 0 over square root of 4 gives us 0. Okay, cosecant is the reciprocal of sine. What's the reciprocal of 0? Okay, secant's the reciprocal of cosine. Reciprocal of 1 is 1. Cotangent's the reciprocal of tangent. So undefined. Is it coming back to you? Okay. I'll give you a couple more minutes to try it for you. We're just trying to practice it. So you fold in your index finger. So sine square root of 1 over 2 is a half. Cosine square root of the bottom, so radical 3 over 2. Tangent square root of the top over square root of the bottom, radical 1 over radical 3, turns into radical 3 over 3. Cosecant, reciprocal of sine is 2. Secant, reciprocal of cosine is 2 over the square root of 3, or 2 radical 3 over 3. Cotangent, reciprocal of tangent, radical 3 over 1, or radical 3. Did we get our 30s? So 45, sine, square root of the top over 2, radical 2 over 2. Cosine, square root of the bottom over 2, radical 2 over 2. Tangent, square root of the top over square root of the bottom, radical 2 over radical 2 is 1. Then reciprocals. The reciprocal of 2 over radical 2. So that's 2 radical 2 over 2, or just square root of 2. So this one's square root of 2, and that one's 1. 60, so sine, radical 3 over 2. Cosine, radical 1 over 2, or 1/2. Tangent, radical 3 over radical 1 is radical 3. Then cosecant, reciprocal of sine, 3 radical 3 over 3. Secant, reciprocal of cosine is 2. Cotangent, reciprocal of tangent would give us radical 3 over 3. And then 90, so if you fold in your pinky. So sine, square root of the top over 2, so square root of 4 over 2 is 1. Cosine, you get 0. Tangent gives us square root of 4 over square root of 0, so undefined. Then cosecant would be 1. Secant would be undefined. And cotangent, reciprocal of undefined is 0. All right. How did you guys do with that? So we should be getting better with this. We are going to keep using it. We will probably practice this table a few more times. I gave you several copies of it for a reason. We're going to practice it. Is everyone understanding the hand trick? How we're using that to get these? Okay. If you don't, please tell me. I have other options I can give you, but I just didn't want to confuse you by giving you 4 different ways to learn this. So I'm trying to teach one way, but if that doesn't work, I have other options. Okay? The next thing I want to do, we're going to start the next section. I did not print notes for you today. Sorry, but it's not a lot of writing today, so you can do that. So we have been focusing on our trig values for the acute angles. So things between 0 and 90 degrees. But we know every angle does not have to be between 0 and 90, so we want to be able to extend this to other angles. So we're going to look at how can we do our trig functions for non-acute angles. I'm not trying to give you more stuff to memorize. We are going to use what we already know in order to get this. So it's not a lot of new stuff, just a couple things that we need to know, and then we'll be able to figure these out. So, first thing I want to talk about today is a reference angle. On all of these questions, when we go to evaluating, I'm going to ask you two things. I'm going to say, what quadrant are you in, and what is your reference angle? A reference angle is a positive angle between the terminal side of an angle and the x-axis. So it's a positive angle between the terminal side and our x-axis. Here's what I mean by it. If you're in the first quadrant, your angle is just itself. But if I gave you this angle, here is our actual angle. The reference angle is a positive angle between the x-axis and the terminal side. So this right here is what's called the reference angle. You'll see that denoted with like a tick mark. So theta is our angle. Theta prime represents the reference angle. It's always positive. It will be an acute angle. So it's between 0 and 90. Just tells you how far to the x-axis. So if I were like in the third quadrant, okay, we know an angle in the third quadrant would look like this. The reference angle is how far it is from the x-axis. So it's just this piece right here. Okay, if I were in the fourth quadrant, so this is my angle. Reference angle would be this part, distance to the x-axis. Yes?
What if your angle was negative, like on the last one?
So then it would just be, I would probably tell you to add 360, just for the sake of having one rule for how to get it. But otherwise, if it were just like negative 60, that just means you went 60 down, so your reference angle is just positive 60. Good question. Other questions? So, first thing I want to do is just practice finding the reference angle. So if I said 30 degrees, 30 degrees is already in the first quadrant, right? So if I just said how far is it from the x-axis, my answer is just 30 degrees. If it's already between 0 and 90, that is your reference angle. B, if I were talking about a 135 degree angle, where does that end? Second quadrant. Okay, so I'm saying this is 135 degrees. How would I get my reference angle? Yes. So this reference angle, 180 minus 135. And we get 45 degrees. If I said 240, what quadrant is 240 in? So if this is 240, how do I get my reference angle? And that would give us 120 though, so that's more. If I do 240 minus 180, I get 60 degrees. So my reference angle is just the 60 right here. If I said 330, that's in the fourth quadrant. how would I get my reference angle there? Same way, except I don't want to use 180 this time. 360. Okay, if I said 210, what quadrant is that? So what would we do to get our reference angle? Okay, if I said 140, what quadrant is that? Second quadrant. How would I get my reference angle? So when I do this, I'm always getting a positive number, so I always have to have my bigger number first when I subtract. Am I ever subtracting from 90 and 270? No, because that would give me distance to the y-axis. I want distance to the x-axis, so I'm either subtracting with 180 or 360 every time. So if we wanted to try to generalize this, like what am I doing each time, it really depends on the quadrant. When we were in quadrant 1, did we have to do anything? No. So in quadrant 1, the reference angle is equal to your regular angle. In quadrant 2, so that was when we had like the 135, the 140. What was I doing? Subtract from 180. So my reference angle was 180 minus my angle. All right. In quadrant 3, what did we do? And in quadrant 4, we subtracted from. So you're always subtracting with 180 or 360. All right, so everybody have this done. All right. That's what we need to be able to evaluate all of our others. So if I give you a non-acute angle, if I give you an angle bigger than 90 degrees, what you are going to do is tell me the quadrant and the reference angle to evaluate. All right, so let's look this up. If I said exact value means with radicals. So you cannot give me a decimal. You can't just plug it into a graphing calculator. It gives you the decimal. We have to be able to evaluate this. Some calculators, I'm going to warn you, do give you the correct answer in radical form. Don't get used to it. On the test, I'm going to make you take a page without a calculator, to make sure you're not trying to use a calculator that just gives you the answer, to make sure you really know this. So, 2 things I'm going to ask. This is your work. What quadrant is 240 degrees in? What is our reference angle? So in quadrant 3, how do we get our reference angle? 240 minus 180. So my reference angle is 60. Okay. Then I want you to think about 2 pieces of information that we already know. I'm in quadrant 3. Tangent is positive, so sine is negative. That's why I looked at the quadrant. So I would know positive or negative. Then I'm talking about 60 degrees. So I go to my hand trick. 60 degrees. What is the sine of 60 degrees? Square root of the top over 2. Radical 3 over 2. So my answer, negative radical 3 over 2. I'm not memorizing any new values. The only difference is my answers could be positive or negative. And I have to use the quadrant to decide which. Right, so if I said the tangent of 315 degrees, what quadrant is 315 in? Does everyone know how we decide the quadrant? Reference angle. In quadrant 4, we subtract from 360, so 360 minus 315 is 45. Alright, all students take calculus. In quadrant 4, cosine is positive, so tangent is negative. 45 degrees, so I do my hand trick. The tangent of 45, square root of the top over square root of the bottom. Radical 2 over radical 2 is 1, so we get negative 1. Cosecant of 300 degrees. What quadrant is 300 in? So reference angle, 360 minus 300 is 60. You might need to take a second and think. The reciprocal of cosecant is what? Sine. So let's think about the sine for a moment. In quadrant 4, is sine positive or negative? Negative. Okay, the sine of 60 degrees is radical 3 over 2. So cosecant would flip it. So we get negative 2 radical 3 over 3. You guys understand how I'm getting these? Let's look at this one. Alright, I want all 6 trig functions for 585 degrees. What should I do first with the 585? Okay, so we get 225. What quadrant is 225 in? Quadrant 3. My reference angle. In quadrant 3, we have to subtract 180. And we get 45 degrees. Okay, so in quadrant 3, I know tangent and cotangent are positive. So the other 4 will be negative. Then I'm looking at 45 degrees. What's the sine of 45 degrees? Sine's the square root of the top over 2, so radical 2 over 2. Cosine square root of the bottom over 2, so radical 2 over 2. Tangent, square root of the top over square root of the bottom, so radical 2 over radical 2 gives us 1. Cosecant is the reciprocal of sine, so we get negative radical 2. Secant, reciprocal of cosine, we get negative radical 2. And cotangent, reciprocal of tangent gives us 1. So we're not learning a bunch of other values, we're not memorizing a ton of angles. We have our 5 basic angles, and everything else just comes from those. All we're looking at is it's going to be a positive or a negative based on our quadrant. Questions there? problem for today. All right, we've had some problems like this before. We just have to evaluate each of these pieces so that we can simplify our entire expression. When I see sine squared of 45 degrees, that means I have to take the sine of 45 degrees and I square my answer. What is the sine of 45 degrees?
2/2.
Plus 3 times the cosine of 135 degrees squared. What quadrant is 135 in? Reference angle, so we subtract from 180. 180 minus 135. 45. In quadrant 2, is cosine positive or negative? Negative. Cosine of 45 degrees? Minus 2 times the tangent of 225. What quadrant is 225 in? Reference angle. We subtract 180. 225 minus 180? 45. In quadrant 3, is tangent positive or negative? Positive. What's the tangent of 45?
1.
And if we square this?
Two.
So on a problem like this, we had them like that in the last chapter too. You're just evaluating each piece. Okay, there is one last type of question in this section, but I'm going to do it tomorrow. I'm going to go ahead and give you the homework. Tomorrow I will do the last type. I will probably do the next section as well. It's a very short section, and you will probably have some class time to work. But you have a chunk of time right now to get started. So this won't be due until Friday. If you look on page 59, questions 11 through 18 are just a big table, and you're filling in. You don't have to write down everything. You're just giving the missing values from the table. So like question 11, if I'm doing that, it told me my angle was 30 degrees. So sine is 1/2, cosine's radical 3/2. They left a blank for tangent. What is the tangent of 30 degrees? Radical 1 over radical 3, so it turns into radical 3/2. Cotangent, reciprocal of it, so radical 3 over radical 1 is radical 3. You don't have to label, you can just put the missing values in order for the table on those questions, if that makes sense.